First of all, I welcome all the students and the participants who are attending this live lecture. See this, in this today's live lecture we shall discuss the solution method of a non-homogeneous differential equation with the variable coefficient. See this. In the previous lecture we have studied from the different 10 theorems how to find out the solution of a homogeneous differential equation with a variable coefficient. All these differential equations are in the linear differential equation of order n. So, in the previous lecture, in the previous 10 lecture, we have seen how to find out the solution of a homogeneous differential equation with variable coefficient. Now here in this lecture we shall discuss how to find out the solution of a non-homogeneous differential equation with the variable coefficients. See this, actually this second unit is totally belonging to the linear differential equation with variable coefficient. Linear differential equation with variable coefficient. See this. Now in that second unit, total second unit, we have discussed the initial value problem, solution of homogeneous equation, Wronskian and linear independence, reduction of the order of homogeneous differential equation. Now in this lecture we shall discuss how to solve the non-homogeneous differential equation with a variable coefficient. See this. Tejashwini Bukan, Samrin Khan, Preeti, Sneha Gaikwad, Maya Wakade, तुमचे homeworks येत नाहीत पहा. So see this, first of all I shall again express here what is the meaning of a non-homogeneous differential equation. An equation of the form L of y which is equals to yn, means y having nth order derivative, or we can write dny by dx raised to n plus a1x yn minus 1 plus a2x a2 of x yn minus 2 plus dot 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 plus an of x y which is equals to here b of x. Note that the right side must be the function of x. So we can say that this is the non-homogeneous differential equation with a variable coefficient, where, or we can write this in this way also, or L of y which is equals to dny by dx raised to n plus a1 of x dn minus 1 y divided by dx raised to n minus 1 plus a2 of x dn minus 2 y divided by dx raised to n minus 2 plus dot 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 plus an of x y which is equals to b of x, where a1 of x, a2 of x, a3 of x dot 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 an of x and b of x be the continuous function, be the continuous functions on an interval I. See this. This form is non-homogeneous differential equation. So in short, we can write this is a L of y which is equals to B of x. This is the homogeneous, non-homogeneous form. And we can write this as secondly we can write L of y which is equals to 0. This is the homogeneous form. See this. And we have seen by using 10 different theorems how to find out the solution of homogeneous differential equation with the variable coefficient. Now see this. Students, now you tell me the order of this differential equation. The order of this differential equation is nth order differential equation. And also we can find the solution by using given first solution. We can find the solution of the second, that is a phi 2 of x. That is phi 1, phi 2, phi 2, phi 3 are the linearly independent of the solution. Okay, very good. सारिका बोलेगा वे बरोबर आहे, तुझं लक्ष आहे. So we can write this in this way. The equation of homogeneous differential equation. यहाँ पे सबसे important बात क्या होती है इस here? A1, A2, A3 dot AN, B be the continuous functions of x. अभी मुझे बताओ students, now you tell me the non-homogeneous differential equation with constant coefficient भी ऐसा ही होता है, ऐसा ही होता है. उसमें क्या फर्क होता है बताओ रे स्टूडेंट मुझे. इसी तरह से ही होता है, लेकिन उसमें क्या फर्क होता है. मैं फिर से आई वांट टू आस्क द नॉन होमोजेनियस डिफरेंशियल इक्वेशन with constant coefficient whose order is n, which is as like this same, then what is the difference between the non-homogeneous nth order differential equation with variable coefficient and non-homogeneous differential equation with constant coefficient. तो यहाँ पे अगर आपको यहाँ पे constant coefficient भी डिफाइन करना है इसी तरह से जो हमने फर्स्ट यूनिट में फर्स्ट चैप्टर में डिस्कस किया है, तो इसको हम कैसे लिख सकते हैं. हाउ टू राइट दिस. नाउ यू टेल मी हाउ कैन राइट दिस इज द हाउ वी कैन से दैट दिस इज अ नॉन होमोजेनियस डिफरेंशियल इक्वेशन विथ कांस्टेंट कोएफिशिएंट. चलो आंसर लिखना है सभी को चैट बॉक्स में. सो नाउ वी शैल डिस्कस द नेक्स्ट थ्योरम, हाउ टू सॉल्व द नॉन होमोजेनियस डिफरेंशियल इक्वेशन with variable coefficient. See this. Actually, the main theorem to solve the homogeneous differential equation with the variable coefficient, we have to consider, this is the theorem number 11. Actually, this is also important theorem here. See this. The statement of the theorem is that let B of x be a continuous on an interval I, and let phi 1, phi 2, phi 3 dot be a basis for the solution of L of y is equals to 0. What is meaning of L of y is equals to 0 means this is the equation of the non-homogeneous form. So L of y is equals to 0 means its homogeneous form, this form. This is a non-homogeneous form because B of x is a function of x. If B of x is equals to 0, then that form goes to the homogeneous form. तो मैंने यहाँ पे आपको एक क्वेश्चन किया था, how we can represent this equation in the non-homogeneous differential equation with constant coefficient. यही एक फर्क होता है उसमें, खाली a1, a2, a3 dot an are the constants, and in variable coefficients a1, a2, a3 are the functions of x. See this functions. यही फर्क. कांस्टेंट की जगह पे अगर आप फंक्शन की जगह पे कंटिन्यूअस फंक्शन की जगह पे अगर आप कांस्टेंट लिखते हैं तो वही नॉन होमोजेनियस डिफरेंशियल इक्वेशन विथ कांस्टेंट कोएफिशिएंट होता है। और यहां पे सेकंड b of x may be or may not be variable. Okay, so this L of y, see this, then every solution psi of L of y which is equals to bx can be written as psi is equals to psi p plus c1 phi 1 plus c2 phi 2 plus cn phi n dot 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 cn phi n, where psi p is the particular solution or particular function of L of y which is equals to bx, and c1 comma c2 dot 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 cn are the constants. Here see this, c1 c2 c3 are the constant. So every such psi solution of L of y which is equals to bx, a particular solution psi p is given by psi p is equals to summation I is equals to 1 to n phi k of x into integral from x0 to x Wronskian of k with respect to t b of t divided by Wronskian of phi 1 comma phi 2 comma phi 3 dot 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 phi n of t dt. अभी यहां पे याद रखना है, see this, the proof of the theorem is the same. The proof of this theorem is the same as like we have seen in the chapter first, that is the non-homogeneous differential equation with constant coefficient. सेम है इसका और उसका प्रूफ करने का तरीका, सॉल्यूशन निकालने का तरीका सेम है, खाली difference is in the solution of homogeneous differential equation. Only there is a difference between the solution of homogeneous differential equation. See this. Now what we have to prove here? We have to show that psi is equals to psi p plus c1 phi 1 plus c2 phi 2 plus dot 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 cn phi n is the solution of given non-homogeneous differential equation L of y which is equals to b of x. And in that case psi p is, we have to also prove psi p is given by summation k is equals to 1 to k phi k of x integral from x naught to x Wronskian k of t into bt divided by Wronskian of phi 1 comma phi 2 dot 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 phi n of t dt. Here x naught is initial 0 0 dot 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 1. In this way we can obtain. See this, proof of this theorem is as like the proof of a theorem which we have studied in the chapter first near theorem number 16. Actually we have proved this. Okay, same. Now we shall see the proof of this theorem. So we can write this size. परत एकदा मी सांगतो, थेरम परत एकदा मी डिस्प्ले करतो, लक्षात ठेवा. सी दिस, ऍक्च्युअली मी थेरमची स्टेटमेंट परत एकदा सांगतो. ओके, नाउ consider the non-homogeneous differential equation of order n is L of y which is equals to y raised to n plus a1x y raised to n minus 1 plus a2x y raised to n minus 2 dot 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 an of x y which is equals to b of x, where a1 comma a2 comma a3 dot 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 an comma b means b of x be the continuous functions on an interval I. यहाँ पे we have considered the non-homogeneous differential equation of order n with variable coefficient. यहाँ पे हमने क्या consider किया है? Non-homogeneous differential equation with variable coefficients. So an, a2, a1 dot 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 an comma b are the continuous functions. Now actually we know that in case of ak, अगर यहाँ पे a1, a2, a3 dot 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 an means generally we can write this as a ak. फॉर ऑल ए के आर कांस्टेंट, अगर ये a1 a2 a3 कांस्टेंट होते हैं तो गिवन डिफरेंशियल इक्वेशन नॉन होमोजेनियस डिफरेंशियल इक्वेशन विथ कांस्टेंट कोएफिशिएंट होता है। और उसके सॉल्यूशन के लिए हमने वी हैव सीन थ्योरम नंबर 12, थ्योरम नंबर 16 in the previous chapter, that is in the chapter 1, how to solve the non-homogeneous differential equation with the constant coefficient. Already we have solved. Then the equation can be solved by the variation method. There in this first chapter we have seen the variation method to solve the non-homogeneous differential equation with the constant coefficient. अगर अब constant coefficient नहीं है, variable coefficient है, तो क्या होता है? In the chapter 2, in this chapter we have seen, also we have seen in this chapter 2, the solution of the homogeneous equation in case of AK are the functions of x, means variable coefficient. अगर variable coefficients होते हैं तो हमने यहां पे थ्योरम 1 से लेकर थ्योरम 10 तक हाउ टू फाइंड आउट द सॉल्यूशन ऑफ homogeneous differential equation with the variable coefficients we have seen. So all are the functions of x in the previous theorem, means from theorem 1 to 9. In the theorem 1 to 10, see this, we have to solve. We have solved, that is reduction of order method or replacement phi 2 is equals to phi 1 of x into integral. We have solved that formula. Different theorems we have seen how to solve the homogeneous differential equation. Homogeneous differential equation means this can be solved by L of y which is equals to 0 with the variable coefficient. See this, okay. So now next we shall discuss, see this, in case of a homogeneous equation we need the particular solution psi p of equation 1, because the particular solution or the particular function psi p is very important. The solution of the differential equation 1 can be written in the form of psi p plus c1 phi 1 plus c2 phi 2 plus cn phi n dot dot dot. Okay, this psi p is called as a particular solution. This psi p is called as a particular solution. Particular solution or particular function. And this part is, see this, and this second part is called as complementary solution, complementary function. This part is obtained by putting L of y which is equals to 0. And this part psi p can be obtained by L of y by taking L of y which is equals to b of x, which we have seen, already seen this part in the chapter 1st. Now see this, where c1 comma c2 dot 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 cn are the constants, phi 1 comma phi 2 dot 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 phi n is the basis of the solution L of y which is equals to 0. अभी L of y which is equals to 0 होता है. चलो स्टूडेंट्स, मैं देखना चाहता हूँ कौन कौन स्टूडेंट्स ऑनलाइन है. अगर L of y is equals to 0 है और रूट्स ऑफ पॉलिनोमियल r1 कॉमा r2 है, तो उसका सॉल्यूशन कैसा लिखना होता है रे स्टूडेंट्स? ज्ञानेश्वर, इंद्रायणी पुजारी, भागवत. नाउ यू टेल मी, इफ r1 and r2 are the solutions of the characteristics polynomial of L of y is equals to 0, then how to write the solution, how to write the complementary function? Write down fast in the chat box. Okay, मैं यहाँ पे जो आंसर देने वाले हैं उनका स्क्रीनशॉट भी लेता हूँ क्योंकि इसकी ज़रूरत है हमें. Okay, now see this. Now see this. Next we shall extend this theorem how to find out the psi p. अभी हमारा प्रॉब्लम क्या है? This is actually psi is equals to psi p plus this. Means this is the complete solution of L of y is equals to bx. Means equation 2 is the complete solution of L of y is equals to Bx. Now, how to find out the Psi-P? Then the Psi-P is given by, we have seen, Psi-P is given by u1 phi 1 plus u2 phi 2 plus u3 phi 3 dot 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 un phi n. By using this we can obtain the Psi-P, where u1 comma u2 dot 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 un are the functions of satisfying the condition. यहाँ पे function u1, u2, u3 are the functions of x, but they satisfies the condition that u1 dash phi 1 plus u2 dash phi 1 plus u3 dash phi 1 dot 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 u1 dash phi 1. See this is the u1 dash phi 1 plus u2 dash phi 2 in this way dot dot un dash phi n. Okay. Secondly, u1 dash phi 1 dash plus u2 dash phi 2 dash plus dot 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 un dash phi n dash. Okay, this is the dash un dash phi n dash. Similarly, dot 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 u1 dash phi 1 n minus 2 plus u2 dash phi n phi 2 n minus 2 dot 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 un dash phi n minus 2 dot dot dot, means these functions satisfies the condition. Similarly, u1 dash phi n minus 1 phi 1 n minus 1 u2 dash phi 2 n minus 1 dot 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 un dash phi 2 n minus 2, which is equals to b of x. The last term is called as a b of x. Let x naught is any initial point of I, we may take uk, then the function given by uk of x is equals to integral from x naught to x wk of t b of t divided by Wronskian of, see this, w of t divided by Wronskian of phi 1 phi 2. See this is the same theorem. The particular function, how to find out the particular function of L of y which is equals to L of y which is equals to b of x is the same process, how to find out L of y which is equals to the same process. See this, in the theorem which we have seen in the chapter first, ये already we have seen, फिर भी हम एक बार मैं रिवाइज करता हूँ. Psi-P, how to find out Psi-P? Psi-P means u1 phi 1 plus u2 phi 2 plus dot 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 un phi n, where u1, u2, u3 dot 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 un are satisfying the conditions u1 phi 1 plus u2 u1 dash phi 1 plus u2 dash phi 2 plus dot 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 un dash phi n is equals to 0. Second, u1 dash phi 1 dash plus u2 dash phi 2 dash plus dot 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 un dash phi n dash. In this way, continuous process u1 dash phi 1 n minus 2 plus u2 dash phi 2 n minus 2 dot dot dot, in this way un dash phi n minus 2 is equals to 0, and the last term u1 dash phi 1 n minus 2 u2 dash phi 2 n minus 2, in this way dot 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 b of x. Let x not be a point on I, then we may take uk, the function uk of x is equals to integral from x0 to x wk of t into b of t divided by Wronskian of phi 1 comma phi 2 dot 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 phi n of k, where k is equals to 1 to n. Means this is the same process which we have studied in the previous chapter, the non-homogeneous differential equation of order n with constant coefficient. Same theorem already we have seen, the non-homogeneous differential equation of order 2, we have seen this same theorem. Now see this, then the Psi-P has the form Psi-P is equals to summation I is equals to 1 to n phi k of x into, this is a uk, integral from x0 to x wk of t into b of t, wk of t into b of t. See this, see this, okay, where Wronskian phi1 comma phi2 dot 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 phi n is the Wronskian of the basis phi1 comma phi2 comma phi3 dot 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 phi n. Also Wk is the determinant obtained from Wk. See this determinant Wk can be obtained from replacing the kth column phi 1, phi k dash, phi k dot 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 means kth column by 0 0 0 1. In this way we can obtain this. But last column we have to replace. Last column of this Wronskian can be replaced by 0 0 0 dot 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 b. We have seen this, and thus we can find the solution. अशा पद्धतीने हा theoremचं solution होतं. See this is a very important theorem. You must know. Theorem number 11. This is a very important theorem. That is this theorem number 11 is based on how to find out the solution of non-homogeneous differential equation of order n with variable coefficients. Okay, now see this completes the proof. लक्षात घ्या, first part जो आहे, in that first part we have to solve by taking L of y is equals to 0 as like previous example. आता याच्या बेस्ड एक एक्झाम्पल घेतो म्हणजे थेरम तुम्हाला परफेक्ट समजेल, काही अडचण येणार नाही. ठीक आहे, आपण एक एक्झाम्पल घेऊ. Write down that example and then we shall discuss. Problem. Example. सबको सॉल्व करना है रे मेरे साथ ही सॉल्व समझ फास्ट आंसर देना है. अभी चैट बॉक्स सभी का अच्छी तरह से चलना चाहिए. देखो see this example. First find all the solutions, find all solutions of the equation y double dash minus 2 divided by x square into y which is equals to x, that is 0 is less than x is less than infinity. चलो रे स्टूडेंट्स, अभी मुझे बताओ. Now you tell me why we can say that this is a non-homogeneous differential equation. सभी ने बताना है why we can say that it is a non-homogeneous differential equation. And second question, how to write its homogeneous form. So I shall write this answer. बहुत अच्छी तरह से बहुत इंटरेस्टिंग प्रॉब्लम है. बहुत अच्छी तरह से हमें सॉल्व करना है इंटरेस्टिंग मेथड से. मैं थोड़े हटके मेथड यहाँ पे यूज करने वाला हूँ. ये किताब की मेथड यूज नहीं करने वाला हूँ. जो भी ये थ्योरम जो है ना, ये थ्योरम यूज नहीं करने वाला हूँ. थोड़ा हटके मेथड यूज करने वाला हूँ. ये इंटीग्रेशन की बजाय दूसरे मेथड से मैं सॉल्व करने वाला हूँ. ठीक है, जो मैंने आपको पहले बताया था, जो भी L of y इज इक्वल्स टू 0 में यूज किया है ना मेथड, वही मेथड से मैं सॉल्व करूंगा. ठीक है, गिवन डिफरेंशियल इक्वेशन इज हा व्हेरी गुड. रचना भागवत, समरीन खान, फक्त दोघाचेच आन्सर आले पहा. पूजा अंदुरे, मनीषा माळी एवढ्यांचंच कॉन्सन्ट्रेशन फक्त आहे इथं बोर्डवर. गिवन डिफरेंशियल इक्वेशन, गिवन नॉन होमोजिनियस डिफरेंशियल इक्वेशन असं लिहू. गिवन नॉन होमोजिनियस डिफरेंशियल इक्वेशन is y double dash minus 2 divided by x square into y which is equals to x, that is for 0 is less than x is less than infinity. This can be written as L of y. This implies that L of y which is equals to b of x. L of y which is equals to b of x. Suppose we consider this equation as a 1. Now we have to find out the solution of this differential equation in two parts. In the first part we have to solve L of y is equals to 0 and calculate complementary function. देखो अभी क्या करना है, इसका solution किस तरह से होता है. देखो the solution of this differential equation is in the form psi is equals to psi p plus C1 phi 1 प्लस C2 phi 2, मैं यहाँ पे लिखता हूँ, मैं थोड़ा आपको डॉट 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 प्लस CN phi n, इस तरह से इसका सॉल्यूशन होता है स्टूडेंट्स। तो psi p मीन्स पर्टिकुलर फंक्शन होता है एंड दिस इज कॉल्ड एज अ कॉम्प्लीमेंट्री फंक्शन, that is C1 phi 1 plus C2 phi 2 is a complementary function, and this can be obtained by taking the differential equation which is in homogeneous form. हे जे C1 phi 1 plus C2 phi 2 जो आहे ना पार्ट, तो कॉम्प्लिमेंटरी फंक्शन असतो and which is obtained by considering L of y is equals to 0. Now to obtain the independent solutions phi 1, obtain the solution in this way. See this, to obtain the solution that is phi 1 phi 2 phi 2 basis solution, to obtain here theorem, see this, let phi 1 phi 2 phi 3 be the basis of the solution L of y. So सबसे पहले वो हमें यूज करना है, to obtain the base, obtain the phi 1 comma phi 2 डॉट 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 phi n. अभी यहां पे सेकंड ऑर्डर डिफरेंशियल इक्वेशन है, सो वी कैन राइट phi 1 comma phi 2 be the solution of L of y which is equals to 0. Therefore, then what we have to take? L of y which is equals to 0. That means y double dash minus 2 divided by x square, y which is equals to 0, but we have to write this in the form of multiplying by x square. So x square y double dash minus 2y which is equals to 0. अभी देखो, this is L of y is equals to 0 form. Now how to solve the L of y is equals to 0? आता सांगा बरे स्टूडेंट्स, आपण हे मेथड सॉल्व केलेली आहे. We have solved number of problems based on this method. Now how to solve? जे ऑनलाइन विद्यार्थी त्यांनी सांगा फर्स्ट. Put, see this, put, how to put? X is equals to e raised to z. Therefore, log x is equals to z. Therefore, dz by dx equals to 1 upon x. चला रे स्टूडेंट सांगा फास्ट. बरोबर आहे का रे? हां, आता काय करायचं नेक्स्ट? फास्ट सांगा रे तुम्ही, तुमचा चॅट बॉक्स कंटिन्यूअस चालला पाहिजे. नाउ फर्स्ट ऑफ ऑल कॅल्क्युलेट dy by dx. dy by dx is equals to dy by dz into dz by dx by the chain rule. So put this value dz by dx means, actually dz by dx means here x. So 1 upon x into dy by dz. Okay, this is the dy by dx. Suppose this is equation number 3. Again we have to find out the d2y by dx square. d2y by dx square also, because we have to put y square in x square into d2y by dx square. So again differentiating also, by differentiating means d by dx of dy by dx which is equals to d by dx of 1 upon x into dy by dx. हाँ बराबर है. So we can write d2y by dx square which is equals to, अभी यहाँ पे हमें प्रोडक्ट रूल यूज करना है. 1 upon x and dy by dx में प्रोडक्ट रूल यूज करना है. फर्स्ट डेरिवेटिव ऑफ फर्स्ट, चला सांगा रे. नाउ यू टेल मी व्हाट इज द डेरिवेटिव ऑफ 1 upon x. 1 upon x चा डेरिवेटिव काय असतो? डेरिवेटिव ऑफ फर्स्ट माइनस 1 upon x स्क्वेअर. सेकंड इज इट इज dy by dz यहां पे dz है, dy by dz plus फर्स्ट एज इट इज 1/x डेरिवेटिव ऑफ सेकंड dy by dz का डेरिवेटिव विथ रिस्पेक्ट टू अगर x लेते हैं तो क्या होता है, d2y by dz स्क्वायर, dy by dz का डेरिवेटिव विथ रिस्पेक्ट टू x d2y by dz स्क्वायर. अगेन वी हैव टू टेक द डेरिवेटिव ऑफ z, so dz by dx, but put this value dz by dx means 1/x, so we get d2y by dx square which is equals to minus 1/x square dy by dz plus 1/x square. See this, how we get the 1/x square, dz by dx means 1/x, and this 1/x, 1/x into 1/x means 1/x square into d2y by dz square. So now transfer this x square on left side, so we can write x square into d2y by dz square, dx square, which is equals to d2y by dz square minus dy by dz. So we can write this as equation number 4. Put 3 and 4 in equation 2, then we get this variable coefficient. See this, equation 2 is the differential equation in homogeneous form with variable coefficient. So we can put this value x square into y double dash. See this, x square into d2y by dx square म्हणजेच y double dash, that can be written as d2y by dz square minus dy by dz, dy by dz. See this, this is a dz. Going to wrong here. सांगत चला रे, रॉंग होत असलं तर सांगत चला. तुम्ही लिहिता लिहिता इथं बऱ्याच वेळा x च्या जागी z असं होत असतं, तुम्ही सांगत चला. So we have replaced this x square into y double dash is replaced by this, okay, minus plus, next we have to write minus 2y which is equals to 0. So this is the homogeneous differential equation L of y in terms of z. This is the homogeneous differential equation in terms of z with a constant coefficient. That means variable coefficient we have converted into the constant coefficient, so we can write this as a 5. Now the characteristics polynomial, काय येतो रे characteristics polynomial? Characteristics polynomial is, see this, p of r which is equals to r square minus r minus 2 which is equals to 0. So we can factorize. सांगा रे काय फॅक्टर पडतात, r square minus r minus 2 चे फॅक्टर सांगा. So we can write r square minus r minus 2 is equals to 0. So r minus 2, r plus 1 which is equals to 0. So r minus 2 is equals to 0, r plus 1 is equals to 0. So r is equals to 2 or r is equals to 1. So therefore this is the second order differential equation. So the roots of a character, therefore the roots of the polynomial is r1 is equals to 2 and r2 is equals to minus 1. Okay, r2 is equals to minus 1. Therefore the complementary function or solution of L of y is equals to 0 is phi is equals to c1 phi 1 plus c2 phi 2. That means c1 e raised to r1 z plus c2 e raised to r2 z. See this, R1 and R2 are the solutions of the characteristics polynomial of this differential equation with respect to z. So we have to write R1z, R2z. So C1 e raised to R1 means 2z plus C2 e raised to minus z, but replace the value of z because our main differential equation is in terms of x. So replace this. So we can write this as a C1 phi1 e raised to 2 into z means काय रे z ची व्हॅल्यू स्टुडंट सांगा, log x plus C2 e raised to minus log x. So we can write C1 e raised to log of x square plus C2 e raised to log of x raised to minus 1. So C1 e चा power log आहे, cancel होतो x square plus C2 x raised to minus 1. That is also called as, this is the complementary function which is denoted by C1 phi1 plus C2 phi2. So here phi1 of x is equals to x square and phi2 of x is equals to what? That is 1 upon x. X raised to minus 1 means 1 upon x. This is the first part. हा काय झाला फर्स्ट पार्ट. आता आपल्याला सेकंड पार्ट कडे जायचंय. सेकंड पार्ट कडे now to obtain the particular solution Psi-P. अभी क्या करना है, हमें पर्टिकुलर सॉल्यूशन Psi-P निकालना है. तो यहां पे देखो, अगर आपको पर्टिकुलर सॉल्यूशन Psi-P निकालना है तो ये देखो इस तरह से भी निकाल सकते हो. फर्स्ट ऑफ ऑल यू हैव टू कैलकुलेट uk by using this integral. By using this integral you can calculate uk and then you can calculate Psi-P. But we have to use the another method. अभी हम क्या करते हैं, दूसरी मेथड यूज करते हैं, शॉर्टकट मेथड यूज करते हैं. सो Psi-P can be written as, हाँ अभी Psi-P means how to calculate Psi-P. यहाँ पे देखो Psi-P means कैसा होता है, Psi-P is equals to actually u1, see this Psi-P, हाँ Psi-P is given by the summation phi1 u1, क्यों u1 phi1 plus u2 phi2. तो हमारे पास phi1 phi2 है, अभी u1 u2 नहीं है तो हमें u1 u2 निकालना है. So we can write this as, now Psi-P is equals to see this Psi-P, we have Psi-P is equals to u1 phi1 plus u2 phi2. So Psi-P is equals to u1 x square plus u2 phi2 means 1 upon x, or we can write x raised to minus 1, where see this, what is the equation number, we can write this equation number 6. suppose इसको हम 6 लिखते हैं, this is a 7, where u1 dash and u2 dash satisfies, see this, according to the theorem u1 and u2, see this, u1 u2 u3 are the functions which satisfying this equation. यहाँ पे ये मेथड यूज करना है, satisfying the conditions. So phi1 u1 dash satisfying the condition, I shall write this condition, phi1 u1 dash plus phi2 u2 dash which is equals to 0, phi1 dash u1 dash plus phi2 dash u2 dash which is equals to b. These conditions satisfies, so this implies that, अभी इसको हम कैसे लिख सकते हैं, phi1 means x square u1 dash plus x raised to minus 1 u2 dash which is equals to 0. आता इथं परत phi1 dash म्हणजे काय येतं सांगा बरे, phi1 dash ची व्हॅल्यू सांगा रे स्टुडंट्स, चला फास्ट सांगा phi1 dash. phi1 dash means phi1 is 2x, so phi1 means x square, phi1 dash means 2x u1 dash plus x raised to minus 2 चा डेरिव्हेटिव्ह minus x raised to minus 2 minus x raised to minus 2 u2 dash which is equals to b. आता याला इक्वेशन सॉल्व करा. सपोज दिस इज इक्वेशन नंबर 8, दिस इज इक्वेशन नंबर 9. नाउ वी हैव टू सॉल्व दीज टू इक्वेशन. वी हैव टू कैलकुलेट u1 डैश. अभी क्या करना है रे स्टूडेंट्स, आपको u1 डैश निकालना है, तो कोएफिशिएंट इक्वेट करना पड़ता है. अगर कोएफिशिएंट इक्वेट करना है, ऑलरेडी इक्वेशन के कोएफिशिएंट इक्वेट है. टू रिड्यूस u2 डैश, सॉल्व इक्वेशन 8 and 9 to reduce u2 dash. So we get x square u1 dash plus x raised to u2 dash which is equals to 0, 2s u1 dash equals to 0. Then this will be get cancelled. This is a b. b means x. Actually this is a b means x. हमने क्या लिखा है देखो, b. b यानी कि x होता है, ठीक है, b यानी कि x. So we can write this size. आता याला कसं लिहिता येईल मग, आता सोल्युशन सांगा रे इथं. हा परत एक महत्वाची बाब आहे, डायरेक्ट सॉल्व नाही होणार, कोएफिशिएंट सेम करावं लागतील. एकच मिनिट. इथं x raised to minus 1 आहे, इथं x raised to minus 2 आहे. मग x raised to minus 2 करण्यासाठी इक्वेशन 1 ला मल्टिप्लाय करा, x raised to minus 1 न मल्टिप्लाय करा, x raised to minus 1 न मल्टिप्लाय करा, म्हणजे x raised to minus 1 into minus 2. हा, सॉल्व इक्वेशन 7 and 8 and 9 to reduce u2 dash by multiplying equation 8 by x raised to minus 1. म्हणजे u2 चे कोएफिशिएंट सेम होतात. देन वी गेट द कोएफिशिएंट ऑफ u2 विल बी इक्वल अँड देन वी कॅन कॅन्सल. आता x raised to minus 2 ला, x raised to 2 ला जर x raised to minus 1 न मल्टिप्लाय केलं तर x u1 dash plus x to minus 2 u2 dash which is equals to 0, and second is it is 2x u1 dash minus x raised to minus 2 into u dash which is equals to 0. So this will be get cancelled. So that is a 3x u1 dash which is equals to, यहाँ पे b है, b यानी कि x होता है यहाँ पे b का मतलब क्या होता है, we can write this x, b यानी कि x, b की वैल्यू b of x is equals to x है. यहाँ पे आप लिख सकते हो b of x is equals to x. So we can write this as a x. Therefore u1 dash is equals to x divided by 3x. So u1 dash is equals to 1 by 3 by taking integral. So u1, this implies that u1 is equals to x by 3 by taking integral. By taking integral u1 is equals to x by 3. आता सेम तुम्ही काय कॅल्क्युलेट करणार, u2 कॅल्क्युलेट, पुट इन 8. देन वी गेट 8 मध्ये ठेवल्यानंतर काय येतं पहा, एक्स स्क्वेअर u1 डॅश, x square into u1 dash means x by 3 plus x raised to minus 1 u2 is equals to 0. So we can write u1 dash ची व्हॅल्यू 1 by 3 आहे पहा. u1 dash म्हणजे किती आहे, u1 dash म्हणजे 1 by 3. So we can write x raised to minus 1 u2 is equals to minus x square by 3. So u2 is equals to minus x cube by 3 u2 dash. So we can write u2 is equals to minus x cube चा डेरिव्हेटिव्ह काय येतो रे, x raised to 4 by 4, 4 into 3 म्हणजेच 12 by integrating. Thus we get u1 of x is equals to x by 3 and u2 of x is equals to minus x raised to 4 by 12. Therefore psi p is equals to u1 phi 1 plus u2 phi 2. So we have particular solution. So we get psi p is equals to, हाँ काय येतं रे, u1 means x by 3, x by 3 into phi 1 म्हणजे पहा, phi 1 म्हणजे phi 1 ची व्हॅल्यू चेक करा, phi 1 किती आले रे, phi 1 x स्क्वेअर, phi 1 म्हणजे x स्क्वेअर मायनस x raised to 4 डिवाइड बाय 12, phi 2 म्हणजे x raised to minus 1. So x cube by 3 minus x cube by 12. So it gives the result 12 minus 3 म्हणजे किती येतं बाप, 12 LCM काढा, 4x cube minus x cube that is 3x cube divided by 12 that is equals to x cube by 4. हा झाला psi p. Hence the required solution, hence final answer लिहितो, hence the required solution is psi is equals to psi p plus c1 phi 1 plus c2 phi 2. That is psi p means what? Psi p means x raised to 3 divide by 4 plus c1 phi 1 म्हणजे रे किती आहे, phi 1 म्हणजे x square plus c2 phi 2 means x raised to minus 1. This is the complete solution of differential equation 1. This is the solution of differential equation 1. ओके, तर या टाईपचं, या मेथडचं प्रॉब्लेम तुम्ही होमवर्क साठी करू शकता. एक प्रॉब्लेम मी तुम्हाला होमवर्क साठी देतो, तुम्ही तो सॉल्व करा. सी दिस. ओके, now solve this second problem. Homework: find all solutions of x square y double dash minus x y dash plus y which is equals to x. 1 minute, which is equals to x. 0 is less than x is less than, suppose this we get infinity. हे होमवर्कला करा रे स्टुडंट्स. ठीक आहे, आपण इथं थांबू. काही अडचण आली तर मी परत एकदा रिवाइज करतो उद्याला, कारण खूप मोठा प्रॉब्लेम आहे. उद्याला परत एकदा रिवाइज करतो. नाउ वी शॅल रिवाइज दिस प्रॉब्लेम टुमॉरो. नाउ वी शॅल स्टॉप हियर. थँक यू. गुड बाय.